So we continue with the sequences. Earlier on, we did just that was just an introduction, right? So now we just continue on how they can try to complicate things before we go to introduction of the series, right? So we are still on sequences. So let's say, for example, they tell you sometimes the answer lies in the statement. They can tell you that maybe in the following arithmetic or in the following geometric or in the following quadratic sequence or whatever. So already if they say that, they've already given me a clue what you're dealing with, right? So that minimizes the work for us, because then we know exactly what we're dealing with. Because the moment they tell you the type of the sequence, you know the exact formula to use for that specific sequence, right? If they give you quadratic, you know you'll use Tn is equal to an squared plus bn plus c. If they give you a geometric, you know that it's ar to the power of n minus 1. If they give you a arithmetic, you know that it will be Tn is equal to a plus in brackets n minus 1 multiplied by d, right? So you know those three formulas, and we are going to add to them when you're doing series, right? So let's say for now they tell you that you have an arithmetic sequence. They tell you that you have an arithmetic sequence. So what do we know about an arithmetic sequence before you can even finish reading the statement? Is that the arithmetic sequence, the difference is common or it's constant, right? The first difference is constant or is common, right? And what do we know about it? We know that it uses this formula, right? That is what we know about the arithmetic, and we know that this represents the first term, this represents any term, and this represents the common difference, whereas this represents your general formula or your nth term, as I said in the previous video, that they can say find the general formula or the nth term. So let's say they tell you that is the arithmetic sequence, and they tell you that term 4 it's equal to -6, right? And they tell you that term 11 is equal to -34. And then the question is solve for determine the arithmetic sequence, right? Determine the arithmetic sequence if the fourth term is -6 and the 11th term is -34, right? So when they say to you determine the sequence, always you give them a minimum of 3 terms, right? Minimum of first 3 terms. Let me be specific. Always when they say to you determine the sequence, you give them the first 3 terms, right? Always give them the first 3 terms. And we know that for us to even get there, we have to find the formula first. For us to get to the first 3 terms, they just gave you the terms randomly. They gave you the first term and the 11th term. There's no really correlation between the two, right? So we have to work it out and find the formula, and then from the formula, then we can find the first 3 terms, right? I hope everything makes sense. So from there, how do we go about to finding the first 3 terms, right? We use what we know. We use what we know so far. So what we know, the formula that I wrote down here, we know that for us, every time they mention the arithmetic sequence, this is what we have to use, right? So what do you do here? You simply substitute what you were given. You were given that term 4, it's equal to, so if we substitute 4 here, wherever we see n, we substitute 4. This is a, is our first term, which we don't have, and then we put 4 minus 1, because we still have n, and n is the same thing, so it's 4. We are dealing with term 4, right? The difference for now, we don't know. So what is 4 minus 1? That is 3, right? So in the end, you will have 3 multiplied by this d, because it's this multiplied by that, right? So we just cut it short and write a plus 3d. This is T4, right? So your T4, which is -6. So we can substitute there and write -6 because we've been given that T4 is equal to -6. So we'll say this is your first equation. What we'll do here is to substitute, right? And then we do the same for the second term, which is term 11, right? So we have term 11 being equal to A, and then we substitute, it will be 11 minus 1 multiplied by D. So we know that this 11 minus 1 will be 10, 10 multiplied by D, that is 10D. So this will be A plus 10D, right? So term 11, and we know that term 11 is set to be equal to -34, right? So already there we have two equations, right? So we no longer need this information, right? So that's the first step. You use the given information to deduce the formula. So we have to deduce an equation, I mean to say, so we have two equations already. So what do you do there? You must make one the subject of the formula. And I would always advise you to make the one which is 1 as its coefficient. That should be the one that should be the subject of the formula. What am I saying? The coefficient here is 3, the coefficient here is 10. For you to make this the subject of the formula, you'll end up making the whole thing to be a fraction, which will make things a little bit more complicated, right? We want to make things easier for us. So you take either of the equations, right? So let's take equation 1. So you'll write it for the examiner, the person will be making that from equation 1, this is what I'm doing, right? I'm taking A, and then you are moving this 6 to the other side, or this 3 to the other side. It doesn't matter, right? So let's take this 3 to the other side. It will be -6 minus 3D, right? We will call this one your equation 3. Now you have 3 equations. So what you'll do now, you take the equation you deduced from the first equation, you substitute it in your second equation. If it happened that we deduced equation 3 from equation 2, you can't substitute it back to the equation you derived it from. I don't know if I'm making sense. You can't take equation 3 and substitute it back into equation 1, right? Because we took equation 3 from equation 1. So we have to substitute equation 3 in equation 2. I hope I'm not making, I'm not confusing you. If the case was that we deduced equation 3 from equation 2, we would substitute equation 3 in equation 1, right? So the aim is you don't substitute it back to where you deduced it from or where you took it from, right? So when we continue, we say that you substitute equation 3 in equation 2. Meaning wherever in equation 2 where we see A, we will put -6 minus 3D, right? So we must always make sure here that you have the correct thing, because if you mess up, the whole thing will be wrong, right? So we have we substitute equation 3 in equation 2. So we will have something like -34. It's equal to, we see A. So where we see A, we must put -6 plus 3D or minus 3D, right? -6 minus 3D plus 10, right? So this -3 plus 10, that would give you something like -7, right? So we'll be having -7D on the other side, -7D, and then you take this 6 to the other side. So it will be -34 plus 6, giving you something like -28, right? And then you divide by -7 on both sides, because what we want is to find the first variable, right? Because we have two variables to solve for us to get here. We have A and D to solve. So here we can find D, and then your D will be equal to, what is 7? What is 28 divided by 7? It is 4. Right? So it's +4, because it's negative and negative, they give you positive. So already we know that our D is equal to 4, right? Oh, this is positive 7, sorry, it's negative 3 plus 10, so it's positive 7, right? So this would be negative D, and then we'll divide by negative. So if we cancel here, that automatically will be negative 4. Sorry, mind the signs. Right? So it's negative 4. So the difference is negative 4. So how do we get from this to finding A? We have two equations, right? So you will select one, right? From either 1 or 2 or 3. But obviously, the obvious one will be 3 because already A in subject 3 is the subject of the formula. A in equation 3 is already the subject of the formula. So we just put negative 4 there, right? So let me just erase this side. So what we will do from here is pretty simple. So this question is normally it's 7 marks and minimum of 6 marks. So from here, what do? You tell the person that you'll be substituting D is equal to negative 4 in equation 3. So meaning wherever you see D in equation 3, you will put negative 4. So it will be A is equal to negative 6 minus 3 multiplied by negative 4, right? So that will give you something like negative 6, negative 3 multiplied by negative, that will be positive 12, right? So your A will be equal to 6 because negative 6 plus 12, that is 6. And then from there, we will have our complete equation being Tn is equal to, for A, we already know it's 6. 6 plus n minus 1, our difference is negative 4, right? So it means that if we want to find the first 3 terms, we can simply substitute here. So term 1, I won't substitute all of them, right? Remember, they said they want the sequence, and we said when they want the sequence, you find the first 3 terms. So for term 1, we put 1 there. 1 minus 1, that will be 0. 0 multiplied by negative 4 is 0. So term 1 will be 6, right? And then what will be term 2? When we substitute with 2 here, it will be 2 minus 1. It's 1. 1 multiplied by negative 4, that's negative 4. And then 6 minus 4, that is 2, right? And then term 3, it will be equal to 3 minus 1, that is 2. 2 multiplied by negative 4, that is negative 8. 6 minus 8, that is negative 2, right? So those will be your first 3 terms. It will be 6, 2, and negative 2. So you get your 6 marks, you are done. Easy stuff, easy stuff. So let's assume they give you something more complicated, right? I'll give you other exercises. Let's assume they give you something of this nature. They tell you that term 5 is equal to x minus 2, and they tell you that term 6 is equal to 2x minus 6, and they tell you that term 7 is equal to 4x minus 8. And they tell you again, so this is minus 6, sorry for the handwriting, so this is minus 6. And then they tell you again that this is still an arithmetic sequence. They tell you that this is an arithmetic sequence. And what's nice is that they gave us the terms in order. We have term 5, 6, and 7. So what do we know if it's an arithmetic sequence? We know in an arithmetic sequence that the differences to be common. So it means if I say term 6 minus term 5, it should give me term 7 minus term 6. So the moment you write this, they will give you a mark because you understand that the difference is common. Remember, I gave you these formulas on the previous video, right? So how do we then work this out? It's easy. From here, you simply substitute, and it's a matter of knowing how to use your signs, right? So 10 6 is 2x minus 6. So we put 2x minus 6, right? We put it in brackets, and then minus 10 5. So 10 5 is x minus 2. It's always good to put your things in brackets so that you don't make mistakes, right? And then 10 7 is 4x minus 8, put it in brackets, minus 10 6, sorry, is 2x minus 6, right? And then from there, you work it out. It's simple, right? So what you simply do from here, it will be, you multiply with that negative, right? You multiply with that negative, so it will be 2x minus 6, negative multiplied by x, that will be negative x, negative multiplied by negative 2, that will be positive 2. And go to the other side, it will be 4x minus 8, and then negative multiplied by 2x, that will be negative 2x, and then negative multiplied by negative 6, that will be positive 6, right? Easy. And then from there, what do? You work out the like terms. So you can see we have 2x minus x, that will give you x. We have negative 6 plus 2, that will give you minus 4. You have 4x minus 2x, that will give you 2x. You have negative 8 plus 6, that will give you negative 2. And then you take the ones with the same variable to the other side, right? So this to the other side, that will be negative x, because it will be 1 minus 2. That will be negative x, and then you take this 4 to the other side, it will be positive, so it will be negative 2 plus 4, right? That will give you 2. So you can't solve for negative x. You must always make sure your variables are positive. So you divide by negative on both sides, and your x will be negative 2, right? So your x is negative 2. Does that mean you solve the answer? No. So always the first question they'll ask you to find a variable, right? So maybe you get five, 6 marks somewhere there, but 6 is too much, maybe 4 or 5 marks, right? And then they ask you to determine the sequence again. I told you that always when they ask you to determine the sequence, you always look for the first 3 terms. So how will you look for the first 3 terms? You will obviously have to substitute and try to find the difference, right? You will always say, try to substitute. So we know that our x is negative 2, right? So what will happen from there? You will have something like these things are easy. These things are easy. They can't trick you. They really can't trick you. So what do you do from there? You substitute. It means that 10 5 will be equal to, what is negative 2 minus 2? That is minus 4, right? So what is 10 6? It's 2 multiplied by negative 2, which is negative 4. Negative 4 minus 6, that's negative 10. And then 10 7, it is equal to 4 multiplied by negative 2, giving us negative 8, right? So what is negative 8 minus 8? That is negative 16, right? So from here we can see that the common difference from them, for them to get from negative 4 to negative 10, they get to minus 6. From them to get from negative 10 to negative 16, they had to minus 6, right? So we can see that the common difference, our D is equal to negative 6. So we don't know what is our A at this point, right? So from here, what do? You go back. This is like the previous example we did, right? Now that you have the terms, it's easy. It's very easy. Don't complicate the things. So what do you have to do? The first thing is obviously to find A first, right? So how can you find A? You take any of the terms, right? You take any of the terms. We know that our D is equal to negative 6, right? So let's work it out. Let's work it out. Let's work it out. Okay, so what do we know? We know that the arithmetic sequence, it will be a plus n minus 1 multiplied by d. So we take n, right? Let's take term 5, which is the easiest, right? It will be t5, it's equal to a plus 5 minus, okay, you'll have to write this down. Let me write it. 5 minus 1, d, we know it's negative 6, right? So term 5, which we know, we said it will be negative 4, right? So let's just write it down that it's negative 4. Let's write it down that it's negative 4. It's negative 4, it's equal to a 5 minus 1, that will be 4, right? So 4 multiplied by negative 6, that will give you something like 24. But it has to be negative because this is negative. So it will be negative 24. Negative 24. So from here, your A is equal to negative 24. You take this to the other side, it will be plus. So it's negative 4 plus 20. That will give you 20. So this is your A. So from here, it means you know that the equation will be Tn is equal to 20 plus n minus 1 minus 6. So this will be the equation, right? So how do you find the first term? You simply substitute. So 1 minus 1 will be 0. 0 multiplied by negative 6, that's 0. So the first term has to be 20. And then the second term has to be 2 minus 1, it's 1. Multiplied by negative 6, that's negative 6. 20 minus 6, that's 14. And then term 3 will be 3 minus 1, which is 2. 2 multiplied by negative 6, that is negative 12. And then 20 minus 12, that's 8. So you can see that the difference, it is 6, right? So it's that easy. So let's continue with, I want us to do an introduction to series, right? I want us to do an introduction to series. So a sequence, what is the difference between a sequence and a series, right? A sequence and a series, they are very similar. However, in series, all the terms are added together. So if you noticed that in sequences, we kept on using this semicolon, right? In series, we add them. So it will be 2 plus 4 plus 6. We don't use a semicolon. Instead, we use a plus sign, right? So the notation used in series is an extension of a notation that is used in sequences, right? And then in sequences, we used Tn for general formula. In series, we use Sn for the sum. So this is for the sum, right? Meaning for the addition, right? And then we used T1 and T2 to refer to the terms. So S1 refers to the sum of the first term, right, and is equal to T1. S2 refers to the sum of the first two terms, so and so. So we use S1 being T1, and S2 will be T1 plus T2, and S3 would be T1 plus T2 plus T3. So that's the difference. There's nothing really much to it, right? So what is important, the first thing is you must know how to prove the series for arithmetic and the one for geometric, right? So let's say this is how you prove it, right? I'll just give you But before we can even prove it, remember that Tn, which is our general formula, is the same as our last term, right? When we were calculating, it is A plus n minus 1 multiplied by t. This last term is the same as Tn. Remember when we were using, in the previous video, I think we used 68, but I think we were given 68 as the last term, something like that. And we said we converted, we put 68 here. So the reason we did that is because 68 was there. We assumed that it was the last term, right? So I hope that makes sense. So how do we prove this? So we keep this in mind, right? Keep this in mind. So how do we prove that? How do we prove the arithmetic, right? So you given that the first equation, you have to do this yourself. So the first equation is A, and we know that for us to get the next 10, like in the sequence of 2, 4, 6, for us to get from 2 to 4, we added 2. From us to get from 4 to 6, we added 2. So we keep on adding the same one. So we can see that for us to get another one, we have to add A plus the difference. And for us to get the next one, we have to add A plus 2 times the difference, right? So this will continue. Then what you will do is that you will reverse the whole thing. So instead of using first term, you use the last term, right? And instead of using plus, you use minus, right? I hope I'm not confusing you. So we start here going to the left. So for this one, it will be the last term minus 2d. The next one will be last term minus d. And then the last one would be last term, right? It's that easy. And then for the second equation, this is equation number 1. For the second equation, what you're doing, you are reversing equation number 1, right? So you would start from the left going that way. So it's L plus L minus D plus L minus 2D, then plus, the reason why we are doing this dashes in between is because we can continue forever, but we don't want to. Ending at 2 is enough. So we are here now, right? So it will be A plus 2D plus A plus D and then plus A. So from here, what do? You add equation 1 to equation 2. They're still together. So Sn plus Sn will be 2Sn. Then A plus Al, this one. Okay, let me try doing this so that you see exactly what I'm talking about. This part, we will add this part, and then we will add this part, and then we will add this, and then we will add this, and then we will add that, and then we will add those, right? It's easy. So from there, what do? A plus L, that will be A plus L. There's nothing that changes. Then we use this plus in between. So this one, A plus D plus L minus D, you see that this D and that D, because it's plus D minus D, they will cancel. We'll be left with A and L, right? So it will be A plus L again. This one, this plus 2D will cancel this minus 2D, so you'll be left with A plus L again, right? So you have those decisions in between, then you continue adding this L plus A, this minus 2D plus this 2D will cancel. So you'll be left with A plus L. So with this one also it's A plus L, and then with the last one also it will be A plus L, A plus L, right? So you see that we have the same thing, it's A plus L, A plus L, and it means if we added terms in between, it will still be A plus L. So what do you simply do from there? we simply say that that is multiplied until Jesus comes, right? So it means that we can put n. N means it can be multiplied until infinity, right? So remember we used n and also when we say we're using the nth term, when we're using the term, we are simply saying until infinity. We don't know where it will end. So until infinity, we can multiply that a plus l, right? And we don't know until when. So we just want the sum, right? So what do? You divide by 2, you divide by 2. So Sn is equal to n a plus l over 2, right? So you've derived your formula. Let me erase, you take a screenshot. But what do we remember? Remember the first thing I told you before we even came to finding the equation. I told you that the last term is the same as um, the last term for the last term for the arithmetic is the same as Tn, which is a plus n minus 1 d, right? So what do you do from there? You substitute into this L, right? So it will be Sn is equal to n over 2, and then this will be a plus, you substitute everything here, right? So let me use a different color. So that will be a plus, let me use a square bracket here so that you see this one, a plus n minus 1 d, right? So you see that we have a and a, they're the same. So you'll be having n over 2, and then open your bracket, that will be 2a, and then plus n minus 1 d, right? So at the end, you'll be having two formulas. You'll be having two formulas that they expect you to know. And you'll be having all this formula here and this one here. So those are the two formulas that you should know. Both of them, we use them to use both of these to find the sum of arithmetic only. So then the question is, when do we use this one and when do we use this one, right? We use the first one when we don't have the last term, and we use this one when we have the last term as it is indicated there. So that will be it for this video. On the next video, I'll start by introducing the geometric, and then we do examples from there. Because we have to be fast because you'll be writing soon. So it means in a day or two, we should finish a chapter. So I hope you understand. Let me know when you're done with the video if you understand.